We're looking at powers in this lesson. Mathematicians invented powers to save us time. They're there to make life easier. They save us doing a lot of writing. Let's go to example B first of all, because that's actually easier. We've got a base, which is a number 3, written how you would normally write a number 3. That's called the base. And then it is raised to a power. That's this little number written in superscript or just above the number. So we've got a base and we've got a power. The power is sometimes known as an index or an exponent. Now, what this means is that we've got 3 and we're going to multiply it by itself. So the power, the little 2, tells us that there are 2 of them here. We've got to be really careful that we don't fall into the trap. A lot of students look at this and think, okay, the power of 2, that means there are 2 3's going on here. And they think that means the same as 2 lots of 3, or 3 times 2, and they think the answer is going to be 6. And if you look at this, you'll see that that's obviously wrong. 3 times 3 is 9. So 3 to the power of 2 is 9. That little 2 means we're timesing 3 by itself. We're not multiplying it by 2. Let's go back to the first example. 2 to the power of 2 is 2 times itself, which is 2. And that equals 4. Now we've got to be really careful again. This is not 2 times that 2. We're not multiplying the base and the power. It's just a coincidence in this case that the answer is 4. But what that little 2 is telling us is that we need to take 2 of these base 2's and multiply them together. Part C is 4 to the power of 2. So that's 4 times itself. And that makes 16. In part D, we've got 7 to the power of 2, which makes 7 times 7, and that equals 49. Writing something to the power of 2 is something that we do so often in maths that we have a special name for it. Take D as an example. We could call this 7 to the power of 2, or we could call it 7 squared. Squared is a quicker way of saying to the power of 2. In the same way, we could say that this thing here is 4 squared. This is 3 squared, and this is 2 squared. It just saves us saying things like 2 to the power of 2. Let's move on to E. Here we've got 2 to the power of 3. And that means we've got 2 times 2 times 2. And if you work that out, you get 2 times 2, which is 4, times it by 2 again to get 8. Again, it's really important that you don't fall into the trap. This is not 2 times 3. The answer is not 6, it's 8. Hopefully you've got the hang of this now. 2 to the power of 4 is just going to be 2 times 2 times 2 times 2. And that equals 16. The power of 4 tells me that I've got to multiply 4 of these 2's together. I'm not doing 4 times 2, I'm doing 2 times 2 times 2 times 2. In part G, we've got 10 to the power of 6. So that means I've got 10 times 10 times 10 times 10 times 10 times 10. Let's just check I've got the right number there. 1, 2, 3, 4, 5, 6. That's 10 to the power of 6. Now multiplying by 10 is really straightforward. So you should be happy that we get 1 million as our answer. Just notice we've got 6 zeros here, and that is the same as the power. That's not a coincidence. That will always be the case when you've got 10 to a nice power. When I say a nice power, what I basically mean is that a nice counting number like 1, 2, 3, 4, and so on. In this lesson, all of the powers are nice whole numbers. But as you do more maths, you will find that you can raise a base to a negative power and even to a fractional power. Let's move on to example H. Here we've got 3 to the power of 5, and that is simply 3 times 3 times 3 times 3 times 3, which is 243. Let's move on to example I. We've got 7 to the power of 1. The power tells us how many 7s we're going to multiply together, and we've just got 1 7. So the answer is actually just 7. I'm not going to multiply it by any more 7s. In example J, we've got 2.5 squared. That simply means 2.5 times 2.5. You can either work this out using your knowledge from lesson N6a, or you can use a calculator to find that the answer is 6.25. In example K, we've got 3.2 to the power of 3. The power of 3 tells us we've got 3.2 times 3.2 times 3.2 again. And that equals 32.768. Finally, in the last example, we have 0.5 squared. That's 0.5 times itself. Again, that's something you should be able to work out using lesson N6a. You get an answer of 0.25. If you're surprised that the answer is smaller than 0.5, remember what this actually means. 0.5 is the same as a half, and we've got half a lot of a half. So half of a half is going to be smaller, and it's actually a quarter, or 0.25. So that is correct. Just a quick tutorial on how to use your calculators to raise a number to a power like this. Most scientific calculators have an x squared button. So if you wanted to do 2.5 squared, for example, you would type in 2.5 and then press the x squared button. Then you'd press equals and it should give you 6.25. That's great if you want to square something, but what if you want to raise something to a higher power? What if you wanted to do 3.2 to the power of 3 and you didn't want to have to type out 3.2 times 3.2 times 3.2? Then there's a different button that you would use on your calculator. It looks a bit like this. You've got an x to the power of a box. So in this particular example, you would type in 3.2, press this x to the power button, and in the space, you'd have to put a 3. That was telling the calculator to do 3.2 to the power of 3. If you wanted to work out a base to a higher power, you would use the same method. You would type in your base, you would press this button, and then in the space you got for the power, you would put in whatever power you wanted. So instead of the power of 3, you could have the power of 4, the power of 5, or whatever number you like.